In this lesson, you will learn how to solve quadratic equations by completing the square. This method works well for equations in standard form. So you'll have 0 equals ax squared plus bx plus c. Remember, that is standard form. In order to solve by completing the square, the a must be equal to 1 and the b must be an even number. It is possible to work with completing the square if a is not 1 and if b is not an even number. However, we will not be learning how to do that. You will only need to complete the square if the equation is in standard form, because when we do the process of completing the square, it changes it to vertex form. So remember, that's a times x minus h squared plus k. That's vertex form. So it cannot be used on equations in vertex form because we need to start with standard form, complete the square, and it becomes vertex form. So let's first look at changing equations from standard form to vertex form. Example number 1. We're going to start with y equals x squared plus 10x plus 12. That is in standard form, ax squared, bx, and c. So we're going to change this to be vertex form. So let's first rewrite the problem. And when we get to our c value, that is not a perfect square number. That's the point of completing the square. We want a perfect square number. So we're going to say plus a blank, move that 12 out of the way, and now say minus a blank. We need to add and subtract the same value to make this equation still equal, but it's just going to look different. In order to fill in that blank, you need to know your b value. We have a b that's equal to 10. So to find the new c value that goes in that blank, so this will be our new c value, you will find half of the b, so b divided by 2, and then square that. So half of the b squared. So let's do that for our equation. Our c value is going to be 10 divided by 2, and we will square that. So 10 divided by 2 is 5. Go ahead and show this step of taking half the b, because we'll need this number again later. 5 squared is 25. So that is the number that goes in your plus and minus a blank. So let's fill that in. So we have plus 25 and minus 25. So the first 3 terms now are a perfect square trinomial. We will factor this, and in factored form, we just write it as 1 parentheses squared. You could go through the process of factoring and get to this factored form, but just know that it's always going to be your x term and then half of your b. So that's where that 5 comes in. So these 3 terms become this 1 parentheses square. And we use the half of b to make our factor. Of course, since half of b was positive, we keep it plus 5. If it would have been negative, we'd say minus. To get the last term, because we're trying to find it in vertex form, we need that plus k. We just combine these values. So 12 take away 25. So 12 minus 25 gives us a negative 13. So we get those by combining these like terms. That's just a constant 12, and we're taking away 25. So that's where that comes from. So that is our equation in vertex form. Y equals x plus 5 quantity squared minus 13. So in vertex form, we can name our vertex. That is the HK ordered pair. So here we're going to look at the 5 and 13. So when you're naming that, recall that we take the opposite and then exact values for our HK ordered pair. This one we do opposite, and this one we do exact. Let's go ahead and look at example number 2. Let's practice another standard to vertex form. So we have y equals x squared minus 18x minus 6. That is in standard form. We are going to change it to vertex form. So let's rewrite it with the plus and minus blanks. So plus a blank, scoot over that term, and be careful, it is a minus 6, so take the sign with you when you scoot it out of the way. We need to find a new value that completes the square. Moving that out of the way, after that we need to say minus a blank. So plus a blank and minus a blank. So your b value is negative 18. We want to take half of that, so negative 18 divided by 2, and we're going to square that. Be especially careful, since our b is negative, keep that in parentheses. So half of negative 18 gives us a negative 9. Again, we still need to square that. And negative 9 squared, think about it, it's negative times negative, it gives you a positive. So your C value that you're putting in your plus and minus blank should always be a positive. Because when you square a negative, it's positive, and when you square a positive, it's positive. So we go from here, and these first 3 terms are now a perfect square trinomial. So the factored form is just x minus half of your b was 9. Of course, keeping that symbol, because half of negative 18 is where we get the negative 9, and we put that in parentheses squared. We combine the negative 6 and negative 81, and that makes negative 87. So for our vertex, we're going to name our HK opposite, so that's 9, and then exact is negative 87. Keep in mind, you can check this in your calculator. So if you go to your y equals on your calculator, type in the original function, x squared minus 18x minus 6. Let's try that again. X squared minus 18x minus 6. And then also type in the vertex form. So parentheses, x minus 9, close parentheses, squared, minus 87. So that's the standard form and the vertex form. So we're first of all saying that they're equal. If we go second table, we should see those equal values in the y column. No matter which way we scroll, up or down, we should see those equal values all throughout the y value column. But we say our vertex is at positive 9, so let's scroll down to that. So positive 9, and look at the y value. It is at negative 87. And because this is quadratic, we should see that would be our vertex. We should see that repetition on either side of our vertex. That's how it makes that U shape. So remember to check it in your calculator. Just type in the standard form and type in the vertex form and go view that table to help you check. So now let's actually solve. What we have been looking at so far have just been functions if you wanted to graph. So now we're going to see an equation to actually solve and get a solution. So we have negative 8x equals x squared minus 20. So recall from the very beginning that in order to solve with this method, it needs to be in standard form. And it does need to be set equal to 0. We want to keep that a value a positive 1, so I'm actually going to add this 8x to both sides in order to get our 0 on one side. This x squared would be our first term. Then we're going to have our positive 8x and finally the minus 20. So get that in standard form in order, ax squared, bx, and c, making sure that it's set equal to 0 before you start solving. So from there we can rewrite our equation with the plus a blank and minus a blank. So x squared plus 8x plus a blank. Then you just move over what you have as your c value. That's a negative 20, so we're moving it out of the way and doing a minus a blank. We need to come up with the c value that's going to make this a perfect square trinomial. That's what it means by completing the square. Find the value that makes it a perfect square. So we take our b value, which is 8. We're going to divide that by 2, so 8 divided by 2, and square that. So 8 divided by 2 is 4. Again, make sure you show that number since we need it again later. So 4 squared gives us 16. So that is the value that goes in the plus and minus blank. The first 3 terms is factorable now. It's a perfect square trinomial. So we factor that as 1 parentheses squared. Inside the parentheses we'll have x plus 4 because half of our b was that 4. Don't forget your exponent squared. And then the last 2 terms we combine. Negative 20 take away 16 is negative 36. All of that is still set equal to 0. So just a reminder, these 3 terms became 1 parentheses squared. And the last 2 terms, we just combined them, being very careful of our signs. That is a negative 20 and negative 16. They combine to a negative 36. So at this point, once you have done the process of completing the square and it now looks like vertex form, you can just undo the operations in order to solve. So if you think about order of operation, we have a grouping symbol of that x plus 4, we have the exponent, and we have some subtraction. So those are the things we need to undo, and we solve in the reverse order of operation. So let's undo the subtraction by adding. 0 plus 36 gives us 6, and of course just bring down the rest of your equation. So that part is done. We now need to undo our exponent. So we're going to undo that by taking the square root of both sides. Recall that when we take the square root of our number, that's a 36. Recall that when we take the square root of our number, we need a plus or minus. 0 plus 36 is 36. We need a plus or minus square root of that 36. Take the square root of the x plus 4 quantity square side. Squaring and square root cancel. That's how come we're doing that operation to get this x plus 4 by itself. The plus or minus square root of 36, that's a perfect square, so that gives us plus or minus 6. So we now have that x plus 4 equals a positive 6 and a negative 6. So let's write it out as 2 separate equations so that we can solve each of them. So negative 6 is going to equal our x plus 4, and positive 6 is going to equal x plus 4. And we'll solve each of those equations. Subtract 4. In your first equation, you get negative 6 take away 4 is negative 10. If it bothers you to have the x on that side, just flip it around. X equals negative 10. Again, subtract 4 here, and we get 6 take away 4 is 2. So our second equation, or our second solution, is positive 2. So in set notation, remember those go least to greatest, negative 10, comma 2. So our equation started as this quadratic that was not in standard form. We wrote it in standard form and did the process of completing the square to solve for the solutions to be -10 and 2. Let's look at example number 4. Here we're going to start with -6x plus x squared minus 52. That's going to equal -12. So notice this is not in standard form. We've got some x squares, x in constant terms, but with not set equal to 0. So we need to do some kind of shifting around before we can actually complete the square. So let's add 12 to both sides, being careful to line it up with the like term. So we're going to bring down -6x plus x squared. -52 plus 12 gives us -40. And now that is set equal to 0 because those cancel one another out. However, it's still not in standard form. We need our ax squared, then our bx, and finally the c. So let's reorder them in the correct order. So x squared minus 6x, being careful that that is negative, so we want to take the sign with the term, and then bring down, of course, our minus 40. So now we can complete the square. We do our plus and minus a blank in order to find the value that completes the square. So plus a blank, scooting over the -40, and then do the minus the blank. So b value, in this case, is -6. We'll take half of that, so -6 divided by 2, and square it. Half of -6 is -3. Always be careful when you're squaring a negative, include those parentheses, so we get +9. The value that you're putting in your plus and your minus blank should always be positive. The first 3 terms, that is now a perfect square trinomial. It can quickly factor to just one parenthesis squared, so x minus 3, and we do the minus 3 because that's half of your b. Keep your exponent squared, so it's one parenthesis squared, and then -40, take away 9, is -49. And of course, all of that is set equal to 0. So we're now ready just to undo the operations. Once we've done the process of completing the square, you just undo the operations to solve for x. So we're going to add 49. We get that x minus 3 quantity squared equals 49. We're going to take the square root of both sides, being careful to remember your plus or minus symbol when you take the square root of your number. So we have x minus 3 equals the plus or minus of 7, because the square root of 49, that's a perfect square, so the square root of 49 is 7. At this point, we need to write 2 equations. We have that x minus 3 equals a positive and a -7. So let's write those out. X minus 3 equals -7, x minus 3 equals +7, and solve each of those equations. When we add 3 to the first equation, we get that x equals -4, and add 3 to the second equation, 7 plus 3, we find that x equals 10. So our solutions in set notation, least to greatest, are 4 and 10. So let's take a look for a moment to see what does this mean if we were to graph these problems. So here, if we go to y equals, you could type the equation here where you set it equal to 0 in standard form, or even the vertex form, but I'm going to start here at the standard form. So x squared minus 6x minus 40. What this means, if I am graphing that equation that's in standard form, if I hit the graph button, I can view a graph of the equation. Of course, we can't see the full quadratic, but we can see close enough to know x equals -4. If you look on the x-axis, there is -4 right where it crosses at the x-intercept. And the same at 10. I know it's right there at the end of the screen, but that 10 means that it's the x-intercept of this graph when we would graph the parabola. It might even be easier to go second table and view this in the table. So if we scroll to -4, there the y value is your 0. And scroll to +10, again your y value is 0. So that's another great way to check your solutions when you solve, making sure that your x value equals 0 in the y column.